Hi, we're doing tables, equations and graphs, 2018 paper, and we're doing question 3b, and this is the third video that we're doing to complete this question. Okay, so last time we were here, we wanted to work out part 3 of the question, and that was we wanted the equation of the total of the blue and the red areas. We got to the stage where we worked out the total area, which was that. We decided it would be a parabola because of the numbers that we've got, because they come down and they go back up and it's symmetrical, so it must be an x squared curve. So we're going to try and show you how to do that on the graphics calculator. So what we're going to do is we're going to enter the R values here on the left and the total area on the right, and that looks like this. Okay, so this is the graphics calculator that I have. So I've entered, if you can see that, so we've entered 1, 2, 3, 4, 51, 39, 39, 51. Okay, so we then hit graph. Usually you will have graph like that. Graph 1, and then you should see the 4 points that you've put in, which makes sense. It should look like that. Okay, and then you're going to press calculate. We want to get a parabola, so we're going to choose an x squared. Okay, so we get a quadratic relationship. A equals this is the form of the equation, and these are the numbers that you have. So if I wrote down that A was 6, that would be a 6 there, x squared plus negative 30x plus 75, and that looks like it does down here. 6x squared minus 30x plus 75. That's my problems are that I've used R and total area, and I haven't got any symbols for it. So now I've used X and Y. If you just write that, you will get marks for that, but you should make it in the context which you're using. So the total area is, and on my left-hand side, the numbers I've been using is R, the radius for the red. So I've got 6R squared minus 30R plus 75, and that will give me 4 marks for that question. Right, working on, we're going to move on and do part 4. Now, part 4, just make it a little bigger. Okay, if you're doing part 4, it says, give the general equation of the graph, which represents the total areas of the red and the blue circles, where the sum of their radii is n. That n is instead of 5, which you've been using up here. So instead of thinking of 5, you need to think of n. So that's where it's a general case. If the radius of the red circle is r, and we're going to use the same as what we've done, and n is the sum of both radii, that's the red and the blue, then the radius of the blue one will be n minus r. Now that's the connection that you have to make. If that's the case, then you have the area of the red, which we've already worked out before, which is 3r squared, and the radius of the blue will be 3 times its radius squared. Now its radius is going to be n minus r squared, because that's n minus r is the radius of the blue. So 3 times the radius squared, and this radius is n minus r squared. So that's the area of the red and area of the blue written in algebra. And what you've been asked for is the total areas, okay? And you want a general equation. If you want a general equation, then what we're going to do is this part here. Total of the area of both will be the red one plus the blue one. So that would be 3n minus r squared, and boom, you've done it. In the answers, they have expanded and stuff like that. You don't need to do that, whoopsies, and that is sufficient by itself. Yay.